Hey everyone, welcome back to the second video in the Chapter 7 series where we're going to be talking about how to form alkenes and reactions to form alkenes. In the very first video, we talked about the E2 reaction, and in this video, we're going to be talking about a similar reaction, which is the E1 reaction. Okay, so we're going to be talking about E1 today. All right. So E1, just like how we talked about with E2, I'm going to talk about some of the important things with E1, and then we're going to go into just a couple examples. Okay, we don't want this video to be too terribly long like the last one, so we'll try and make this quick and easy. So E1, similarly to E2, prefers 3-degree alkyl halides over 2-degree over 1-degree. All right, so 3-degree and 2-degree are going to go through E1 pretty easily. All right. And then another thing about E1, and this is similar to SN1, right? Another thing about E1 is that it requires a weak base. Okay, weak base is what it requires. Okay, so as opposed to what we were looking at in E2, right? E2 is a strong base. In this case, we're not using strong, we're using weak. All right. The other thing is that heat is applied to the reaction. And we'll see that later. But that's also a very important part of E1. Now for the rate equation, so our rate equals our rate constant, Kr. And this is the same rate equation as SN1. Okay, so this is just concentration of alkyl halide. So if we go back to the SN1 video where we talk about the rate equation, just concentration of alkyl halide times the rate constant. That's it. Okay, so that's our rate equation for this. Also similar to SN1, this is a two-step reaction. Okay, it's not concerted, so there is a carbocation intermediate. So 2 steps. And it has a carbocation intermediate. Okay, so that's a very important thing that we need to know about this reaction. And then the other thing that we need to know is that, like in E2, we talked about E2. Remember, and if you don't remember this, I would recommend that you go back and check out the E2 video. But in the E2 video, we talked about that the halogen and the hydrogen that is being removed had to be 180 degrees, had to be anti-coplanar, anti-periplanar from each other. In this case, we don't have that. It doesn't matter, okay? So what I'm going to say is there's no geometry requirements. So E2 has geometry requirements, but E1 does not. Okay. And then finally, we spoke about the Zaitsev and Hoffman products in the E2 video. E1 forms the Zaitsev product. As the major product. Okay, so this is our bullet pointed list of the E1 reaction. Okay, this is all the important stuffs about E1. So we'll get further into what each of these mean in a couple of examples, and we'll do the mechanism for each of those as well. But I just wanted to kind of start off with this so we could see exactly what's going on. So let's go now and do a couple of examples here. So I'm going to start off with the same thing that we started off with. Well, this one's actually going to be slightly different. We'll start off with this. I was going to start off with the same thing we did in the E2 video, but I think we should start off with this instead. So now, I want a weak base. Water's a weak base. And then instead of listing a solvent, I'm just going to heat it. Okay, so the triangle, the delta, means heat. All right. So I'm going to be taking this alkyl bromide and heating it in water. Okay. that's important because with the heat, that's going to be forcing an E1 reaction. Because you think about it, if I don't put this heat here, right? If I just pretend heat isn't here, that's just H2O with the bromine, right? The alkyl bromide. This would just go through SN1, right? So that's a problem with E1. That's why we don't do E1 typically, because with E1, right? With E1, what can happen is SN1 will also happen at the same time, right? So anytime we're doing an E1 reaction, SN1 is also going to be happening. Okay, so we have to keep that in mind. So we're going to be doing substitution and elimination. So we try and heat it to make sure that SN1 doesn't happen as often, but it will still happen. Okay, so there is a competing factor there, which is not great. Okay, so but I'm just going to be drawing the elimination products here. I'm just going to be drawing the alkenes, but just know that SN1 does also occur here. Okay, it does also occur. Okay, so let's do the mechanism, and then we'll kind of speak a little bit about exactly what else is going on. Okay. So we start off with our alkyl bromide, and just like in SN1, the very first step is that the bromine just leaves. So our leaving group leaves. That's our ionization step, okay? And that's the rate determining step. That's the slowest step, okay? So now we get a carbocation here, and we also get Br minus as well, all right? So now our base is just going to come in, which is water in this case. Our base is going to come in and it's going to take a hydrogen. So if you remember in E2, we take a hydrogen and the electrons go there to form the bond. Same thing in E1, right? Our base comes in this case it's just a weak base, it comes in and it takes a hydrogen, and then we form our double bond. Okay, so we're going to form a double bond here and water is going to gain a hydrogen. Okay, so then that means that my final product is this alkene as well as a protonated water, which is hydronium. So I get this alkene and I also get hydronium as well. Okay, and that's the whole mechanism. All right, so we get this. So two things I want to mention here. The very first thing is that I could have also taken a hydrogen from here, right? There's 3 hydrogens here. There's 3 hydrogens here. I can, right? I can take a hydrogen from here, but the problem is that if I take a hydrogen from here, that's going to form a less substituted alkene, right? So if I take a hydrogen from here, then I'm going to get a less substituted alkene. I'm going to get the Hofmann product. Remember I said earlier that E1 is going to form the Zaitsev product in the major product, okay? So this is the major product because it's more substituted, all right? And then the other thing to mention is that in E1, okay, we have this carbocation intermediate, and remember that these bonds, these single bonds are always rotating very quickly, right? And since there's no geometry requirement for SN1, I can form this one, but think about if this bond just slightly rotated, right? If it rotated and just so happened to look like this, like if that bond rotated and it looked like this, and then I took a hydrogen off, right? If I take this hydrogen and then that forms there, well, what does that give me? Well, then I get this, right? I get this. And you'll notice that this one is trans, this one's cis, okay? Or this one is E and this one is Z. So what I'm trying to get at here is that E1 forms both E and Z products. Okay, so I'm going to get rid of what I just drew because I don't want it to be confusing with what the mechanism is. But it forms both E, so this one's E, and I also get Z. So this is also major, and this is Z, okay? Or cis in this case. And then I also get the minor product, which I mentioned earlier. This is the minor product. Okay. And I would also get E and Z of the minor product, except in this case, there's no E and Z for this molecule. So if I was asked to draw the major product or products of this reaction, I'm drawing both of these. I'm drawing the E and the Z. Okay. And I would not include minor. Okay. Just like in E2. E2 also makes minor products, but if I'm just asked to draw the major product, I just draw the major. So in a E1 reaction, I'm going to be drawing just these two, the E and the Z major products. Okay. Okay. So now that we've looked at that, there's a couple other things that I want to mention. All right. So the first thing is that I can get rearrangements, right? Rearrangements are possible in this reaction, which complicates this slightly. All right. So let's take a look at an example of a rearrangement. So let's do this one. And I can get hydride shift, methyl shift, ring expansion, anything in this, but let's do this one. And then we'll put this through methanol and heat it up. Okay. So in this case, I'm going to get a couple products here. But this is my major. Because it's most substituted, this is Zaitsev. And then my minor is going to be this. So this is my major, this is my minor, okay? So again, if I was asked to draw the major product on the exam, I would draw just this one, okay? But let's do the mechanism for this so we can kind of understand what's going on here. Because why am I getting those double bonds where I'm supposed to be getting, where I'm getting them, right? So what's going to happen here is I'm going to have a hydride shift, like I said. So first step is that chlorine leaves, all right? And then after that, I get a carbocation here, and then I can have a hydride shift. So this hydrogen can go here, right? And then that's going to be my hydride shift. So I'm going to write hydride shift, okay? And then that's going to move my carbocation to here. So then I can take a hydrogen from here or from one of these two, right? So in order to form a minor product, I take a hydrogen from this carbon, but I'm just forming this major product. I'm writing the mechanism for the major one, so that's all I'm concerned about currently. So I'm going to take this hydrogen. That's going to go there and form the double bond. Then I form this double bond, okay? And then I also get a protonated methanol. So that's CH3OH2, positive charge, and it has that lone pair on it, okay? So this is my mechanism. This is my hydride shift, okay? And, you know, I can have a hydride shift, a methyl shift, a ring expansion, literally anything, okay? So just, you know, try and keep that in mind. I would do a lot of practice problems and practice examples with hydride shifts and methyl shifts and ring expansions, just so we could, you know, you kind of get used to those and you kind of know what's going on there. And then, you know, remember I can also get E and Z here, but E and Z, since I have two methyls here, E and Z does not come into play with either of these two molecules. So that's why I haven't worried about E and Z. But you would also get E and Z. All right. But like I said, there is no E or Z for this molecule. This is the only form of it. Same thing for this one. All right. So I think that is all that I'll mention about E1. I think E1 is substantially easier than E2 because there's not as much going on, but I think the mechanism is a little bit more in depth, right? We have a carbocation intermediate, but that's not anything new. It's not anything we haven't seen before, right? So just remember that with the carbocation intermediate, I can also have rearrangements. Okay. So that's something to keep in mind. So, you want to be on the lookout for those hydride shifts, those methyl shifts, those ring expansions, things like that. Okay. And like I said, I would definitely make sure to do some practice problems with these mechanisms just so that way you are a little bit more ready for seeing those types of things. Okay. So hopefully this video was helpful. And in the very next video, we're going to be talking about dehydration, which is very, very, very similar to E1. So if you're good at E1, you will be just fine with dehydration. So do not worry about that whatsoever. So appreciate you watching this, and I will see you in the next video.